Hello.
Hello.
What is different between get logs and eth call?
Uh, Get logs doesn't have to actually run anything because the logs were already run and most clients save them.
Hmm.
Whereas eth call will execute some code on top of some block and then give you the results. And in fact, very annoyingly to most people, eth call doesn't actually return any logs. And so eth simulate does. That was one of the big wins of eth simulate over eth call is that you actually get logs back. And it's super annoying when you're writing applications and you don't get logs, but you do get a return value if you execute a contract off chain, like the ETH call, and you do get a return value, but you don't get logs if you look at a past execution that happened on chain. Because it makes building your application just so much harder when the result set is different between on versus off chain.
So in this feature that Aragon was trying to develop, they actually allow execution of additional code on top. So
Yeah, so we've been talking to Benteg a little bit in our server, and I think I have a better understanding of what they're doing now. It appears what they're doing is they want to be able to say, okay, over the last 10 million blocks, pick out the set that expressed this log line, and they use that as like an indicator, like a flag to say this transaction touched this contract. And then from that subset of transactions and all the last 8 million blocks what they're looking at, uh, now rerun those transactions. So run those transactions again, that subset, but with this code at address X instead of the normal code at address X, and where their replacement code maybe has some new events or new logs. And then return me all the logs from those executions.
so they rerun only the ones that are related to this particular contract.
Yeah, and unfortunately, the way they identify that, because the only information that's stored about what contracts are called are logs that were fired. And so, if you call a particular contract but the log is never emitted for some reason, let's like say the log is in a conditional statement, right? Um, if that condition is not met and therefore the log was not emitted, their technique will skip over that contract, even though maybe it would have still fired the log. And this is necessary to make it so they can do their thing in reasonable time frame, because you can't just re-execute 8 million blocks worth of transactions
Hmm.
in any reasonable time, right? So they need to narrow that down. The technique they use to do that is say anything that had this log in it, rerun, but rerun it with this code instead, but using the same state. And so you do need an archive node for this because you need to be able to execute with the same state again.
Hmm.
So I do think their thing is different enough from ours. Like it's serving a different goal. Um, you could, in theory, and we talked to them a little bit about this in our chat. I think you could reproduce their results with ETH Simulate, but it would be much more heavyweight and involve a lot more round trips. So with their thing, you just tell the server, look for any transaction that fired these events, and then rerun those transactions with this code replaced. And all of that can be executed then on the server side. You don't need to have round trips back and forth between the client. Whereas if you want to do the same thing with ETH Simulate, you would need to basically go to the server, ask it, please tell me all the places where this log showed up in the last n blocks. And then the client would get that, build out a set of ETH Simulate calls, and then call an ETH Simulate for every single block that showed up in that set of events with those set of events. And so there's a huge amount of round trips if you were to use our ETH Simulate to solve the same problem versus if you use their stuff to solve that problem. It's a single round trip, and the node does everything, and it can have optimizations that make it fast. Whereas if you simulate no optimizations, it would re-execute everything. It's going to return results that are much bigger. And so I think they serve different enough purposes that I can see value in having both separately.
So do I understand it correctly that if like compared one to another, filtering of certain transactions in history running through like block ranges and rerunning transactions that are only filtered out based on some criteria would be the like essential difference between what Simulate currently does and what their thing is doing.
Yeah, I'd say that's the biggest difference. Just the fact that you can kind of you tell it, I want you to rerun some subset of things. Here's the filter that will tell you what that subset of things is, and here's the code I want you to replace when you do the re-execution. And you're giving all that up front, and you're telling it, and do this over a very large range of blocks. Whereas Simulate, we're basically saying each of these calls is we're just saying, I want you to run this set of transactions in its entirety and give me all the results. So that's the other thing, is they will only give you back the results that are the events. They're not going to give, like, if you do an Simulate, you get back the whole blocks, right? You get blocks, all the receipts, and every transaction that occurred. Like, it can get pretty bulky. And so, so yeah, I think what you described is the biggest, and the second biggest thing is just the volume of results that get returned. It's going to be much smaller for theirs because it's very narrowly targeted what they're looking for.
It will be smaller because it only returns logs, or what would be the difference?
Yeah, so it only returns logs, and it only returns logs for the specific subset of transactions that you care about. And so you still need to, in both cases, you still need to execute all the transactions in the block prior to the transaction of interest to you, right? So if your transaction showed up at transaction number 53 in the block, you still have to, in both cases, you still have to execute transactions 1 through 52. In their case, they execute transaction 1 through 52, and then they execute transaction 53, return the results, and they stop. Whereas in our case, we execute all the transactions 1 through 52 plus all the transactions 53 plus 54 through 100, and then return all the results for every single transaction. And so it's just a lot more bulky of a just protocol, because it's serving very different purposes.
Mm-hmm. So basically, in terms of collaboration with them, we probably potentially want to align the RPCs somewhat a little bit closer to make them, or what do we think about?
I could see some use in just having the shape of the data structures be similar. It's always nice, when you're, as an app developer, it's nice when the same data structures are used over and over rather than having completely different data structures, or even worse, two data structures that are very similar, but like they're different in how they do casing or how they do naming, just in a subtle way, because then it makes it really easy to get mixed up and get it wrong. A canonical example of this, right, is depending on what client you're using for a long time, it was input versus data as the field, the data field for transactions was sometimes input, sometimes data, depending on what context you're in. And this was super confusing for app developers because everything else was the same, except for that one field was named differently. And so I think with Simulate and their thing, the get logs thing, I think just having similar data structures where it makes sense may be valuable just in terms of synchronization. Again, just for ease of use by app developers.
I guess the use case for that is the shadow logs. Or is that completely different, the shadow logs things?
You're talking about the overlay get logs, the use case?
Yeah,
I mean, the use case makes sense to me. So some contract developer writes some contracts, and you're using those contracts. Or maybe you're building some sort of analytics software that cares about what's happening in those contracts. But the app developer or the contract developer didn't think to put in the logs you need, right? And so you now want to do some, you want to do some big analytics or on what's going on internally, but the logs are simply not present. And so you're saying, I want things to execute exactly as they did. I don't want to change execution. I just want to change. I just want a different set of outputs. I want you to give me different details about what's happening. And you can do this with tracing, right? So tracing tells you literally everything that happened, every single operation, opcode. But that's really heavyweight. To do a full trace on 8 million blocks is insane. That would take you weeks. And so instead, the idea here is we can do a much more narrowed sort of tracing that gives you very kind of the inner details that you want without needing to do a bunch of really heavyweight stuff on the node.
I guess Etherscan and the explorers are doing that tracing everything.
I believe so. They have the advantage though, is that sort of. So they have their own internal indexes that they maintain, and those indexes I think do require them to do tracing on every single call. But if they want to add some new index, they need to retrace the entire blockchain, right? Because they need to go do everything and build a whole new index. Whereas if you're trying to do some data analytics and you just kind of want a one-time answer, or you want to go back and get some data, but you know where to find that data, you don't necessarily want to retrace the entire blockchain. You don't want to spend 2 weeks on a big beefy server just running retracing the whole blockchain just so you can pick out one new piece of information. And so I think the idea with this overlay git logs is you can get that exactly what you want at a fairly low cost. And it does come with a disadvantage. And I think sounds like from my talk with Vantake that this is okay with them. It does come with a minor disadvantage that if the contract of interest to you doesn't always fire a log in the executions where you need the data, you don't have a good way of figuring out which transactions to re-execute. And so they're using this concept that we're assuming, starting from the assumption that some log was fired to let us know this contract was executed. So that we know to re-execute it with this new code in place that will fire new logs. If you don't have that, like let's say you had some contract that was deployed and is always called internally and doesn't fire any logs ever, then you wouldn't be able to use this to redo it because you wouldn't know which transactions you need to rerun. So again, disadvantage, but I think the trade-off there, I can see definitely why that's worth it because that's almost an impossible problem to solve without in a reasonable amount of time, unless you just literally index the entire blockchain with some petabyte index set of indexes that indexes like every opcode and every contract that was called. Then maybe you could do something like that. What is trace filter?
But I wonder what this would mean to us, that this doesn't sound something that we can implement in the each simulate, and it should be a different method.
Yes, I don't think we should merge this in my personal opinion is. As for, I mean, honestly, well, Aragon went ahead and merged this. So, but just thinking about this method, it seems like, yes, you will have to do a lot of re-executions, especially when coming from East get logs. You might think that large block ranges are okay, but that's because we fetch stuff from database. But here you would have to actually re-execute all those transactions and blocks, which is quite a lot more overhead. And my second concern is that it's easy to shoot yourself in the foot because when you're doing the state override, let's say if you add a view function, that's fine. But if you add another function that kind of changes the state in different ways, like it also calls another contract that modifies something, then I don't know, like, what are the implications of that exactly?
I think you definitely get weird results out. But from my understanding of the use case is primarily around basically just extracting more data out of the executions, not about changing the behavior at all. In fact, I think they explicitly don't want to change behavior. They just want more data out of what happens when those transactions were executed.
So I think this is all about leveraging new Aragon archive index that is now per transaction diffs, so they can not execute anything beyond what they have to. So probably.
What is this new index from Aragon?
So before they were indexing diffs per block, and now they want to, I'm not sure if this is released or not, but they will want to index them by transaction, right? So they can execute one transaction from the middle of the block without executing any prior transactions.
Just to make sure I understand, you're saying that basically they're storing a pre-state for every single transaction rather than just the pre-state for a block.
Yeah, exactly.
Gotcha.
Exactly. That's what they are trying to do now.
More archival version of an archival node.
Yeah. That's Aragon, 3 or 4, whatever. I don't know what number they're on. And yeah, so that's probably leveraging that a lot.
Yep.
So unless you have similar database design, this might not be completely for you.
Yeah, I think if you want to do this in a database in a client that did not have such a database, at best you'd have to use an archive node, and you'd have to re-execute all the transactions up until the one that was interested to you, at the very least.
Mm-hmm.
I am kind of curious, just, I don't know, I'm guessing no one here knows the answer off the top of their head. I'm curious how big the archival database would be if the index included every contract that was touched as part of each transaction's execution. So for any given transaction, you would index, okay, these transactions were touched within that transaction, or sorry, these addresses were touched within that transaction. Touched meaning either called or had, I guess just called, yeah, called or had like a nonce or account change or code change. So less than 420 gigabytes. No, it's got to be more than 420 gigabytes.
Okay, thinking about it a little bit. Well, hard to say. Well, it should be a few gigabytes, a few terabytes. Sorry.
Yeah, I would think it would be measured in ones or tens of terabytes, because an archive node, which just stores the state, and deduplicated state at that, for all of history, is measured in terabytes. If you then wanted to take every single transaction, I guess, okay, maybe that's the wrong way to look at it. So I guess we'd want to look at the total number of transactions in all of history, and then kind of average out, okay, how many addresses were touched on average in each one, and that would be your number, ballpark.
When you say that, like to keep all the utilized addresses, do you mean index? It would mean not only index the addresses that were directly called, but also indirectly, for example.
Yes.
Mm-hmm.
Yeah, and ideally do it, have the index both go transaction to address and address to transaction. So that way you could say, for this address, show me all the transactions in all of history that ever touched this address in some way. And that way, in a single small query, you do a single index lookup, and you would get a list. And in terms of performance, you get a very high performance. In terms of, you're basically trading storage for performance there, right? So your index gives you a really fast return result on all the hits of touches of this contract in all of history, but you pay a lot in terms of disk space. Yeah, TrueBlocks has an interesting solution to this. I looked into it a while back. They don't track calls, though, I think. I think they only track when an account was referenced, but not when it was called. I think it's slightly different, but yes, maybe that's a good kind of proxy for size-wise, because I think their thing is on the order of single-digit gigabytes for their indexes.
Should we discuss about each simulate?
Yeah,
forward.
Probably should.
Oleg, do you have updates?
Yeah, currently basically cleaning up the code for the future last review for it to be merged. Haven't yet looked into the hash difference between Nethermind and Guess, but we'll do this soon on the local Hive.
Okay, Sina.
Yeah. So last week I looked into some reports from Killary and did some fixes. Basically, our base fee was computed incorrectly when there were phantom blocks in the middle. I also added withdrawals to the block result, as well as excess block gas and block gas used. Now, it is kind of interesting question. What to return for excess block gas when there are phantom blocks in the middle.
And this is because the excess block gas calculation is a function of prior blocks, right?
The parent, basically, yes.
Is it just parent?
It's
Not like parent,
well,
parent?
I mean, I guess the parent then depends on the parent, so it's like a moving
Sure.
average.
Yeah, so very similar to
Base
EIP
fee.
1559 base fee calculation. Yeah.
Exactly. So
Can we just do the same thing?
That's what I did. So basically, what I did was ignore the fact that there were phantom blocks, and I just assumed that the last block was the last real block. We just
That
have
seems
to make sure
reasonable.
that we do the same thing on Nethermind as well.
Yeah, yep, we do the same thing.
Okay, that sounds good. Then there was the other issue when the gas price is 0, then the base fee is set to 0 on the EVM, but it still returned something else for the base fee. That was something that was difference between Get and Nethermind.
Yes, yes. So we have this logic that if the gas price is 0, if simulate by default, we set the base fee to 0 for the purpose of exposing it to the EVM. So when a contract calls the base fee opcode, then it returns 0. And we did this because it seems to be a common pattern to do TX gas price minus block base fee. And it would have returned a negative number in this case, which is like kind of undefined.
I didn't think about the negative number part. It's unfortunate though, because hypothetically, one could design a contract that is dependent on base fee never being 0 because it is technically impossible to reach 0. It can never go below 7, just due to the way the formula works. And so one could imagine a hypothetical contract that, broke very badly if it was ever 0. I think, though, that the issue you were worried about return negative numbers is worse. And so I think I'd rather have the problem of some obscure random contract breaking, and because you can always fix that by just specifying a base fee, right?
Mm-hmm.
Yeah. So
yeah,
okay,
if you specify gas price, then it's gonna, and you can also specify base fee. Well, yeah, you'd have to have a gas price as well.
So I don't know how Nethermind manages that. Does it always set a base fee?
Yeah, we are looking for, so there's a comparison between the gas spent and gas owned and gas available in a block. If you would post me this issue once more on Trello, I probably would be able to look at it again and fix it soonish. And also I had a question, which Hive test currently would provide us with the as complete pre-built block and transactions as possible? Like, in which ones do we have, in which test do we have as much defined as possible in terms of like block data and transaction data? So basically, I want to check a case when, say, we had every field in the block possible filled up, every field in transaction, if possible, filled up. And if there would be difference in hash between us and guess, then I'll know that there is something fundamentally different. And if there will be no difference, I'll be able to like eliminate field by field, 1, second, third, 3, 4, etc. And find out the field, the specific field that is subject to change of the hash. So if we could have such a test where we have like field as much as possible block and field as much as possible transaction, that would be perfect.
I think the easiest one is just, does it need to be contract calls, or can it just be a bunch of ETH transfers? I think it's very easy to fill a block with just like 1,000 ETH transfers.
Two would be enough.
2? They said you wanted the block full.
Oh yeah.
So each ETH transfer is, I guess there's 2 ways to do this. One, you write a little contract.
You can set gas price.
Even then, still the gas cost is going to be 21,000 each, right? And so if you have a 30 million, I guess you set the block size really low. So if you just set your block limit to 42,000, and you can have two transactions that are ETH transfers, each costing exactly 21,000. They don't do anything. It's a very simple version of this test. Would that be sufficient for you?
Mm-hmm. Yep.
Okay. You don't need anything fancy. The contracts don't need, or the transactions don't need to do anything special or be fancy or anything. They just need to have transactions and fill the block gas.
Yeah, that would be perfect basic start.
Okay. Is that something that you can do, Kalar, you think?
Yeah, I can do that. I just said the test that's the code that just returns the base fee. And at the moment, get and Nethermind is disagreeing on the output on this. And the get is returning 0, and then Nethermind is returning something else. It's returning non-zero base fee.
Mm-hmm.
And this is what we're discussing with Sina.
Right. And here I would like to point out another quirk. I'm kind of open to changing this, but basically the base fee opcode in this case in gas returns 0. However, when we return the base fee as part of the block result, then it's a real base fee value. It's not 0. So there is this kind of inconsistency that I noticed when Hillary pointed out the issue. But I guess I'm open to changing this based on the result of the discussion here, like seeing what we want to do in general.
So help me better understand this negative number issue then. If you were to have the opcode base fee that was the same matched whatever you would have returned or whatever you returned as part of the base fee for the block, why would that yield a negative number exactly?
That's when you would do like TX gas price minus block base fee. Because gas price would be 0 in a simulation.
I see. You're allowing 0 gas price even when the base fee is greater than 0, which in reality can never actually occur.
Yeah, exactly. Gas price should always be higher.
So I guess this is not a problem where in Geth or Nethermind you have to deal with this negative number. This is just someone's Solidity contract that was designed to, under the assumption that the number can never be negative, would break. And so the solution could be solved purely by the user, by just, if they have such a contract, they could then set the gas price to larger than the base fee, and that would fix it, right?
Yes, they would. If they specify the gas price, then that would fix it.
Okay, I think I changed my position then. I think having the opcode return the same thing that the block will return is more important, because in both cases, whichever route we go, the user can ultimately solve their problem by just specifying the gas price and the base fee explicitly. And so I don't care much about, if someone's random contract that does something weird like this breaks in any simulate and they have a workaround that allows them to make it not break, I'm totally fine with that. But I feel like it's worse. It's better to have some users have to do that than to have inconsistent results, such as your EVM opcode doesn't match your JSON RPC result. And so I think my position is now those two should match.
Yeah, I think it's also very weird when I'm getting different base fee and its block is returning.
But we do also have the option of returning 0 in the block result.
Yeah, that's one option.
Yeah, but I mean, we already have the code for correctly calculating the base fee for some definition of correct, and I think I would prefer personally to keep that. I'm not super strong on that argument.
I mean, the semantics of gas price being larger than base fee is kind of, I mean, it is part of the yellow paper, let's say, or the protocol.
Could we just? Is this one of those things of like validation mode on versus off? If we had a validation mode that we all agreed on and it was on, then this would not be a problem. Would that be an accurate assessment?
Yep.
Okay, so this is purely a problem of we're trying to make things easy for the user by setting things to 0 that normally cannot be 0, and allowing and ignoring, not doing validation of things that don't make sense. And so we don't want to just return an error if the user ends up in a situation where the base fee is higher than the gas price, because we want things to just work and be simple. But that then leads to weird results that don't make sense. Like,
But should it work?
this is the whole debate of validation mode versus non-validation mode, right? In validation mode, this should not work. Like, you should just get an error, and it should just tell you you're doing something dumb. Don't do that. In non-validation mode, we're trying to make it. It's the difference of like TypeScript versus statically typed versus dynamically typed language, right? The statically typed language stops you early and fast and says, "No, you made a mistake. Don't do that." Whereas dynamic language is like, "Yeah, sure, go ahead and add your number in your string. We'll figure out. We'll make that make sense, sort of." And then sometimes the dynamic language, you're going to get a weird result out at the end because the language let you do something that doesn't make sense. And I think it's the same general line of argumentation here, where the validation mode is the statically typed equivalent. Stop you early from doing things that don't make sense to the system.
So my question would be then, can we have some formulation that would like create default values that are like that could potentially work with validation mode on and won't like in most scenarios, and keep and place them into validation mode off also?
So I think the problem we run into is that we're going to have, in validation mode off, we're going to have to violate something if we have the goal of making it so users' transactions just work. The primary reason for this is we want to make it so people can execute things without needing money to cover gas fees. And since base fee can never actually go to zero technically, it means either we need to allow base fee to go to zero, which again is against consensus protocol rules, or we need to allow the gas price to be lower than the base fee and the transaction still execute, which is again against consensus rules. Or we need to, I think those are two options, right? In either case, we're violating a consensus rule. We just have to choose which consensus rule we violate. Or I guess the third option is we don't allow people to have gasless transactions. But I'm pretty sure we want people to have gasless transactions in non-validating mode.
Can we insert like sane defaults for like transaction that is given to us as gasless, but to like fill the gas values for it automatically?
I guess one option is you say the defaults are transactions are not gasless, but we automatically fund every account with some gas money. So you just give everybody ETH. I think the problem there is you're going to run into weird things where people aren't expecting accounts to suddenly mint ETH out of nowhere, right? And so you can then be a little smarter about it and say only give ETH to accounts that are executing where the account is the to address of a transaction, and that address doesn't have any ETH at all, like its balance is exactly zero, and only give it enough ETH such that gas limit times max fee per gas is the amount you're giving it. So that would be a way. I'll leave it to the client developers. It sounds like it's adding quite a bit of complexity to our implementation to do something like that, but that would solve the problem as well. So that way it's, you can submit transactions from any address, doesn't need to have ETH in it, but the transactions are fully valid by default. And the reason they're valid is because we're basically covering your gas fee by just minting you some ETH beforehand, unless you explicitly tell us not to mint you ETH, in which case we will then not do so. So if you explicitly say, set this account's balance to zero as part of the override, then we would not do that thing, and instead you'd get bizarre, weird results.
That last part made it all a bit more complicated.
Right. Yeah, I agree with Benteg. It is definitely useful to sometimes call from addresses that have no ETH. In fact, we went to quite a bit of length to make it so that's possible. Like, we're overriding the rule that you can't initiate transactions from a contract, specifically so you can do exactly that. So I guess it's complexity versus violating rule A versus violate rule B. Those are our three choices. Or take away useful feature.
Could you elaborate which rules are rule A and rule B?
Sure. So we'll say rule A is the base fee cannot go below 7. That's a consensus rule. It's like the spec doesn't allow it to go below 7 ever. Rule B is that the gas price can never be less than the base fee of the block.
I think the first one, where we allow it to be less than 7, may be a bit easier, because then all other stuff would still work, regarding the like always positive stuff like that.
Yeah, like I mean, I can imagine a contract that breaks in either case. I think both cases are unlikely to be broken. I think it's just we just have to make a call. I'm okay with either, really. Now, you can imagine a contract that, you know, some math doesn't work if the denominator is 0, like you could divide by 0 error, and they assume that the base fee can never be 0, and that's the denominator of some function. But if that's the one you guys want to go with, I'm fine with it.
Sina, what would you suggest?
Well, I mean, we already have this implemented as basically we took route B. But I think regardless of which one of these rules we choose, we do have to also specify what to return in the block result.
Should if base fee is not defined by the block, should we set it to 0? I guess that's the question.
Yep.
Like at the moment, it's assumed that it's going according to the normal rules, but now in my example, the user is not defining it. So it becomes that transaction would normally fail if.
Just to answer Sina's question, my preference is that we should always return the same thing in the EVM and the JSON RPC result. So if within the EVM the base fee is seen as 0, then we should return 0 as the base fee for that transaction / block / whatever. And that one I do feel a little bit strongly about. I'd argue for a little bit to support that one. I have very little care for whether we go with option 1 or 2 here for the other.
But should we set the default base fee to be 0 if the user is not setting it?
Yeah, so if we went with 1, then I would say yes. The way to solve this is just to set the base fee to 0.
That would mean that if you set the validation mode true, then it would always fail unless you calculate the base fee yourself. And at the moment, we have the multi-simulate calculate the base fee for yourself, so you don't need to calculate it. But then it's
we can make it so validation. Yeah, we can make it so validation true sets the base fee accurately, but you don't have this other problem, or rather, yeah, this other problem doesn't exist because we would also default the gas price to be greater than 0 in validation mode. So both of them would be valid and higher. And then in non-validating mode, we'd default the base fee to 0 and the gas price to 0.
I think there is one more approach potentially we could take. We can replace the sender of the transaction with something like system address, or this is not a good idea.
I think we still have the same problem in the end because I think the same bug will show up if the user specifies a source address from, but they don't specify the base fee or the gas price.
Mm-hmm.
So we still have to solve this either way. What is the default from address that we're using right now? Is it 0?
Yes.
I think that depends on the client.
Oh, we should make sure those are the same. Do we not have a test for that?
I mean, ETH call, I think it depends on there, but I don't think we have test for that.
No, we should get a test that just leaves the from out and has some contract that outputs different results based on what the from address was.
Yeah.
Maybe just something as simple as just return the from address. Does anyone have strong opinions on whether to go with 1 or 2 here for non-validating mode? Do we allow base fee to be 0, or do we allow gas price to be less than base fee?
Not really. I can go with whatever is comfortable for gas.
I would go with gas price being lower than base fee.
You prefer that one? Okay. It sounds like Cena has a mild preference for that just because you already have the code written. You wouldn't have to change anything. So we've got 2 people that have a very mild preference for 2. Let's go with 2.
Well, actually, I have my preference for 1 because that's what we have to.
Okay, so Geth has 2 written. Another mind would like to write 2, but has 1 written, and Geth would like to write 2, but has 1 written. Got it. Anyone want to argue?
How does it
for
work
one or the other?
when those are different? Is there, we don't get any negative numbers anywhere if we allow that?
So in the EVM, you would have a negative number, which is basically is likely to overflow in someone's contract somewhere. So if someone's contract does gas price minus base fee, they're expecting that number to be positive. It's going to overflow, and solidity checks may even say this is a checked math that will always give you a positive number. But in simulate, that number could actually become negative, and therefore you're going to overflow, and it's going to get 0x a really big number, and then something's going to break. It's all hypothetical. I can't imagine why someone. That's not true. I can imagine people writing contracts that do gas price minus base fee.
But what should then my call return? Should it return the 0 or should it return the normal base fee?
If we went with 1, it would return 0 if the user did not set the base fee explicitly.
Yeah, it's not set.
Yeah. So it would return 0 in your little call there. If we went with 2, then it's going to return whatever the calculated base fee is.
I think that's what Nethermind is doing because that's what it's returning. But I guess with the 0, the problem is that if you set the validation mode true, then I think that would fail even if you add the gap. You have to override the block base fee because
So
it's not being
validation mode
calculated anymore.
fail with defaults anyway because gas price should be set explicitly.
Oh yeah, that's true. But yeah, but when you set that, then is the base, or then the base fee, I guess it gets calculated out. It's validating the base fee, I guess, with the validation mode.
So the one argument I have for 1, which I'm not going to defend this, but the argument I can think of is that 2 is much more likely to happen in the wild. I think 1 is much less likely to happen in the wild. I think there are probably 0 to 1 contracts in the wild today and possibly in the foreseeable future that do that have like something divided by base fee, where they're going to get a divide by 0 error. Whereas the number 2 scenario, I think actually exists in the wild today and is not uncommon. It's any contract that's trying to calculate gas premium for the transaction that's being executed, which is frequently used in things like meta transactions and stuff like that.
I think this corner case was found by Peter because he has this Chad NFT project that basically you can take ownership of an NFT when the base fee goes higher than the latest claim. So he certainly faced this issue, and that's why he fixed it.
I see. And he faced the issue because you guys had number 2 implemented, right?
Yeah, number 2 is the default. Number 2 is if you don't do anything, then you have number 2.
And Lucas, you said you preferred 2 or you preferred 1? Sorry, I forgot.
I preferred 2.
Okay, and why don't you like? Why don't you like 1?
Okay,
What's the
we can do
reason?
one, but I don't know. Base fee calculation was pretty well defined. I'm not sure if what would it need to change it. Maybe it's not a big deal. I don't know.
Yeah, I think all of us agree that it's not a big deal either way. We just need to pick one.
Yeah.
Just one, two were like more in line what we're doing on other potential places, right? Like feels more natural to me. What I'm used to.
Yeah, let's should we postpone this decision to next week?
Sure. If someone come up with a good argument either way by next week. If not, we'll flip a coin and choose one.
Nice. And could you, Kelari, please update the Trello with the issues that we are currently having so that I could brush up on them also, if there are any?
Yeah, I had some issues with the test RPC, and I guess Sina fixed it, and then I can run it again. And then I can see what are the differences now.
Perfect.
Cool.
Or did you push the PR to the test RPC, but I guess needs to be merged, or I need to refer to that?
You can make those changes just like 2 lines. You can make it in your local repo and already do the testing until that gets merged upstream.
Okay. Do you have anything else?
Well, there was a topic that kind of was discussed shortly last week about removing phantom blocks. Now, Micah was pretty set against it. But we said we would discuss it this week as well. So just bringing it up in case.
Could you elaborate on what did we mean by removing phantom blocks?
Basically, what I mean is we would require the user to provide every subsequent block, as in the number has to be strictly increasing by 1.
Oh. Why?
So my reasoning was that phantom blocks are kind of weird, especially in places where we have moving averages, for example, in the case of base fee and excess blob gas. These are things that move with each, like these are values that get adjusted with each block. And the approach that we took now is kind of unintuitive to the user, I think, because when you have 100 empty blocks, that means the gas used is 0. That means like for 100 blocks, the base fee should go down. But we're not actually doing this.
Yeah, I think I see where you and our mental models differ. For the phantom blocks, I've always imagined them as not empty blocks, but just like, average blocks. Like here's between block N and block M, where you've got like a 100 block space. I in my head, my mental model, I'm like, okay, there's some blocks there, they're normal, average, whatever, meaning the base fee doesn't change because they're middle of the road full, middle of the road not interesting, just a bunch of ETH transfers or whatever. Again, just the mental model in my head sounds like maybe it's different, which is perhaps part of why we're disagreeing on this.
Exactly. I think it's like they are confusing, and we've had to kind of add a whole section to the documentation because of these phantom blocks. And basically it came up for me when implementing beacon routes. So the thing with, and we have that whole complicated thing with block hashes. So very unintuitive, we had to invent a scheme to calculate the block hashes for phantom blocks, which is kind of just really hacky, it feels to me. And we have the same thing now with phantom blocks, so we would have to invent another scheme for that, because beacon roots can be, so we basically contracts can access the beacon roots for the last 8,000 blocks.
What do you mean the beacon root can access last 1,000 blocks?
Well,
oh, you mean
the beacon roots contract. So basically,
I
users
see.
can request the beacon roots for the last 8,000 blocks. And that means that when we have phantom blocks, we kind of have to, somehow we have to return something there, and we would have to add them to this system contract.
Is that a new thing that's coming, or
That's already shipped. It was part of the last fork.
okay.
Yeah,
I didn't know about
I
that.
only realized recently that we need to add support for this in a simulate and ETH call.
Yeah, because this is the first time that we've had a basically contract update from the system, right? Previously, contract updates always occur due to transactions that execute. I think it's the first time in Ethereum's history where the system itself, wrote to some address as storage.
Exactly. So at the beginning of every block, we would have to do this extra processing to add the beacon root for that block to the actual try.
Right. So I agree with Sina wholeheartedly that phantom blocks add a lot of complexity. So I'm not disagreeing on that at all. I think for me, I just see it as complexity that is worth it for the benefit of being able to have very large gaps of time that are accurately represented. Now, I think the thing that would convince me otherwise, like if I was going to argue against myself here, play devil's advocate, any well-written contract should use timestamps for large spans of time. They should not be saying, after 1 million blocks have passed, do X, or have X as some function of number of blocks passed. Like that is not the way you should be writing your contracts. You should always be using a timestamp on Ethereum. Like you should, if what you think you care about is time passed, you should be using timestamp. You should not assume that blocks are 12 seconds. You should not make any assumption about stuff like that. And there are essentially no use case that I can think of where you actually care about how many blocks have passed.
But it would cost more, wouldn't it, to look at the time comparison in comparison with looking into the block number?
In both cases, it's just two numbers minus each other. So I think the cost should be identical. In one case, you're just doing block.timestamp minus your saved timestamp. The other one, you're doing block.number minus your saved number. So I think the execution costs are identical in both, I believe. The one place I could see you maybe counting blocks is if you've got some system where the number of blocks that have been produced since a previous thing occurred, it lets you calculate like the security parameter, some security parameter, right? And so you've got so your security of your system is a function of number of blocks passed between 2 points in time. And it's not a function of how much time has passed. So if 1,000 blocks happen in 4 seconds, then you're just as secure as if 1,000 blocks happened in a month. And so I can imagine that, but that's a pretty far-fetched kind of construction, and I don't think anyone's doing that. And so the argument against my position in favor of Sina's position is just that no one should be writing contracts that do block number minus prior block number. And so we don't need the ability to simulate large spans of block numbers. We just need this ability to simulate large spans of time. And we can do that by just allowing block n to have a timestamp of x, and block n plus 1 to have a timestamp of x plus 1,000,000. And we currently allow that. And so I think that's my argument against myself. I don't know if it wins. Kalari, yes, on Ethereum mainnet today, blocks happen every 12 seconds. Well, no, slots happen every 12 seconds. Blocks do not necessarily happen every 12 seconds. Blocks happen on mod 12-second intervals. That being said, it is not set in stone that will never change. And in networks that are Ethereum-like, but not exactly Ethereum, those numbers can change. And one could easily imagine, and there are dev nets that have that number different, that are Ethereum dev nets, not public test nets, but the internal dev ones often change that number as well. And even like, I think you can spin up Netherminds and Geth both with like their out of the box dev test net. And I think it's got 1 second block times. And so it's just generally a bad practice to assume blocks are 12 seconds, which is, so no one should be doing that, especially when you have a literal clock. Yeah.
How does the beacon roots work? Is every block or every slot need to have a beacon root? And if you're doing each symbol like this, we are creating new blocks, then do we also need to calculate some kind of block root for every block as well?
I would love to know the answer to that question. What happens when you have a missed block? Does the beacon root get 2 updates in 1 block?
No, only
No.
the beacon block that is corresponding to the EL block will have the update.
Okay, so if you have a missed slot, you would basically you'd update the beacon roots with a hole. Is that, or sorry, you'd update the beacon roots, and that would result in a hole in the list.
No, because you can have the same height EL blocks on different CL blocks.
Oh, I see. So it's a this is beacon roots are a function of EL block number, not slot number.
I think
or indexed
so.
by
I'm not entirely sure. I would have to double check. Sina, do you know?
I think so too. I think they are related to EL blocks, not CL.
I see. Okay.
So if you simulate 10 blocks forward, do we also need to calculate those roots for those 10 blocks?
If we were doing these shadow blocks, then yeah, we need to backfill. And this is, I agree with Sina, this does add some complexity that I hadn't considered.
I'm meaning just that when you normally create the new blocks that are one after another and no phantom blocks, do we need to calculate some beacon roots for those as well?
Yeah, we need to update the beacon root state for each one of those. And we should have tests for that.
Basically, then the question would be that if I'm a user that wants to simulate block number 1 and block number million, I would need to stick in like 999, 999 empty blocks with gas price 0 for this same thing to work for me. Yeah?
Yes, and you would almost certainly get throttled, or if you're running your own node, you'd crash your own node.
No, you don't really need
Not
to.
really.
No, you don't really need to put blocks anywhere. It's just you need to update the state correctly with 999 hashes in the state. So you don't really need to put any blocks. It's just a simple state update, to be honest.
So we'd have to adjust our JSON RPC API to support something like that. Or are you saying we would use the same API we've got right now, but instead of doing these phantom blocks, we would actually, generate some blocks, get some hashes, update the beacon roots, et cetera, for each one of these along the way.
Oh, okay, that's what you mean. So why would you generate a block to get a hash? Like, I don't get it.
Well, if we got rid of this, if we just got rid of the whole concept of phantom blocks, then the client, like, there's no virtual blocks at all. Like, every single block actually was a thing that was executed. It may have 0 transactions, and execution may have been short, but it was treated exactly like if you specified every single block along the way. It may have all defaults, that's fine, but you've got
okay, but we don't have but this is about beacon roots, right? We don't have beacon roots in ETH simulating anyway.
I think we're saying we should update beacon root.
Yeah, so we should add beacon roots to the block overrides.
Okay.
And we should calculate it properly if you're not overriding it.
What do you mean calculate properly?
Meaning, as you iterate over blocks, we actually do fill in the beacon root Merkle tree, or we have some sort of virtual function that
beacon root Merkle tree. How would you feel beacon root Merkle tree?
Whatever the data structure is that's storing all these beacon roots, right? So in the contract, I have the contract.
We would just fill in default beacon roots, and that would maybe be the 0 hash.
Yeah, what data would you put as a beacon root of a block where you don't have a explicit beacon root?
I see what you're saying. So you're saying for each simulate, we literally would just be making something up.
Yes.
To put in here.
Yes, exactly.
Okay. And so it's either a random number, like some sort of deterministic random number, or it's just a fixed value each time, like the 0 hash or whatever.
Yes,
Yeah, okay.
it's either a fixed value. We can have like a consecutive counter because it's basically you know, viewing 256 in some other way.
Yeah.
So we can have just a counter, put block number there as a counter, right? Whatever, right? We can do multiple things.
Yeah. Okay. I think I'm very slowly
or an
coming
empty
around.
hash.
I'm slowly coming around to Sina's point of view, just in that this is one of those things where there's like lots of little tiny bits of complexity that are just starting to add up, and Beacon Roots is just simply the latest one, where our phantom
Yeah.
blocks are adding lots of little tiny bits of complexity. No individual one is bad. Like, we can solve all of them, but there's a lot of them.
In my opinion, phantom blocks don't add complexity here too much, because you have the same complexity if you just don't override this. You still have to put something there.
And in my opinion, users would just fill in with nearly empty dummy data. And I think there won't be any issue for the node to process block that is extremely empty. It won't consume any real gas. So
Yeah. So
Well, let's say we simulate block n and block n plus 1 million.
yes.
I mean, so if we don't have phantom blocks, then you are going to have to do some amount of execution for each of those.
No, keep phantom blocks. If you didn't override block
Yeah, I'm sorry. I'm
roots, then you just returns empty hash for it, and that's be done with it, right? Regardless if you have phantom or non-phantom blocks.
So the point here is that you would need to go ahead and do this state update for all of these 1 million blocks. Or you would have to write some specialized code that does this lazy evaluation.
Yes.
right.
And
Because
I
the
would do
contract
the lazy
in-
one, to be honest.
All right, I agree. I think that's, like, from a performance standpoint, lazy one's definitely the way to go here. But that's now, again, more complexity in the clients to support phantom blocks. One more small piece of complexity, but it's additive to all the other complexity we're getting just for support for phantom blocks. And so I think the question that Sina is, the broad question Sina is trying to propose, and I'm slowly coming around to, is that we just keep adding the phantom blocks are adding lots of little pieces of complexity, and it's not clear that they provide the commensurate value to users, especially since users should be doing timestamp based stuff anyways.
And my question here is that, like, given that we want to support those features, is it possible somehow to like override something in those contracts to make their time span a bit shorter so that they do fit in 200 blocks that I can actually do a simulate on without
Not
needing
automatic.
blocks?
Yeah, not automatically. Like the things people do with timestamps are often, complex DeFi Lego things where you're like, okay, I need to calculate continuously or per second compounding interest, and so they have some function that calculates compounding interest over some span of time, and that's going to be very wrong if you don't have the proper amount of time. That being said, anyone doing that should be using timestamps, and so removing phantom block support would not break them if they correctly use timestamps. It would only break them if they had compounding interest as a function of block number, where it's like each block compounds the interest a little bit. And if you're doing that, which again is a very bad idea, you shouldn't do that. But if you did that and we don't allow phantom blocks, then you can't simulate into the future.
Hmm.
If you're using the block hash somewhere, then that also breaks.
I think
Why did block hash break?
Because if you want to change a transaction that refers a block hash, and then you want the block hash to match something, then you might need phantom blocks to do that.
Okay, I have a very very cool idea.
Okay.
So if someone supplies you these overrides, then you override, right? That's simple thing. But if someone doesn't supply you override, you just do nothing. And because this, if I remember correctly, this is like a round robin list. that you go through it in the actual implementation, then you would just return some data that is from some other block, but it would be consistent in different implementations. You just do nothing and you just return it.
So you're saying that we have some kind of placeholder pre-built blocks that we just all agree on?
No, I'm not saying it. Because you're starting from some state, right? From the main blockchain, and it has some values there, right?
Yep.
So
What if the chain is less than 8,000 blocks old?
then there would be zeros
Hmm.
if you read them, right?
Yeah.
So no problem.
Yeah, I think also to counter Mikkel's point, one thing is that if you allow users to override timestamp, and at the same time you limit the ability to override block number, it would feel like a pain, because you want to override them both together. You want your phantom blocks to exist if you can have phantom time.
So yeah, I mean that is the broad general argument for phantom blocks, is allowing users to override anything, and that includes down to the block number. I struggle to think of legitimate cases where a user actually cares to override the block number. Bantek, if you know of some situations where overriding block number would be useful, that'd be super helpful. I'm struggling to think of cases where you want to do that, and it makes sense, not just you're doing something stupid, or you should have been using timestamp. We can continue discussing this, and it is late. Sorry, I didn't realize it was past our normal stopping time. Perhaps we can continue discussing this in Telegram. And like I said, I'm starting to come around, so maybe I can re-engage with you there, Sina, more on this.
Yeah, sure.
I guess we need to also discuss the bigger routes and how we are going to implement those, if we want to add those as well. We can continue that in Telegram as well.
Yeah, let's do a sync and continue next week. Thank you all guys for coming.
Good.
See you.
Thank you. Bye.
Thanks all.
Thanks.